So like we have two kinds of physical quantities, scalars and vectors. So the rules governing scalars are simple. We know that 3 plus 4 equals to 7 and 5 minus 3 equals to 2, and see how we can write it in another way. Like we are simply adding minus 3 and that's you get 2. So this is what we have started studying right from class 6th. So subtraction is also kind of addition, okay, it's type of addition. And then we have multiplication. 4 multiply 5 equals to 20. So addition, subtraction and multiplication. Now if you look at the vectors, how do we add vectors? Because scalars have only magnitude. So but the vectors, they have magnitude and direction. So the results that you will be getting, either you are adding the vector, addition of vectors, or subtraction of vectors, or multiplication of vectors. These rules are, of course, because direction is involved. So how do we so the resultant vector after addition, subtraction, multiplication, the resultant vector that you will get, like here these are the results that you are getting. So they are also the magnitude, but here the resultants that you will be getting, so after addition, multiplication, subtraction, the resultants that you will be getting are vectors. So of course the resultants, the results, as they are vectors, so they will have two things, magnitude and direction. So magnitude and direction. So this is the difference. So that is why we have vector algebra, and in physics we need to deal with lots and lots of vectors, so physical quantities which are vectors. So definitely we should know how to add, subtract and multiply them. So the only basic difference between a scalar and vector, that a scalar quantity is a quantity with magnitude only, and it is specified by a single member along with proper units. Like you have speed, so that is speed, suppose it is 15 meters per second, but here if you are writing velocity, then if it is 15 meters per second, you need to tell the direction also if you are writing the vector. So direction, like if this is, so in how many ways you can tell the direction? You can simply tell the direction in if this is east direction, so in the east direction, in the east direction. What other way to tell this direction? Like if this is suppose x-axis, so you can tell the direction. This is vector I cap, unit vector, so 15 meters per second I cap. So instead of writing, you can also write it along x-axis. Yes, you can also write it like 15 meters per second I cap, or this is O and here I have A, okay, so you can also write it 15 meters per second along OA. So O to A, along OA means O to A. So vector quantities, you have to write the direction also, then only it will be written properly. And these are the different ways of telling the direction. And if general vector we have to write like vector A is equals to its magnitude, like this is the magnitude, and then the direction. And direction, this is the best way you can see that this is the simplest way. Just so whatever the direction, let's suppose this is vector A, and so this is the magnitude, this length, this is the magnitude. Okay, now what about direction? Take the unit vector in the same direction, so that is A cap, this unit vector, and so magnitude multiplied by its direction, which is unit vector. So that's how we write a vector. And in terms of R, if I write this as vector R, this is the position vector, this is origin, this point is suppose P, so OP, so this is again this is unit vector in the direction R. So I will write it as this vector R is equals to this vector R is equals to magnitude, this much of length is R, into its direction multiplied with the unit vector. So that's how we write a vector, magnitude multiplied by its direction. Okay, so now first step we have seen how to write a vector. Now let us see the addition of vectors. So, and the next thing you can say that equality of vectors. So two vectors can only be equal if they have same direction and same magnitude, then only they will be equal. So equality of vectors, so equal vectors have same magnitude and direction. Okay, then only vectors are equal. Now multiplication of vector and scalar, what does this mean? Multiplication of vector with scalar quantity. So it means we represent the scalar quantity with lambda. Okay, suppose this vector A and I am multiplying it with A. What does this mean? This means this is my vector A, and now I am multiplying it with suppose 2. So multiplying with scalar is going to change the magnitude. Direction will remain the same. So direction will remain the same, but this has become 2A. So here lambda is equals to 2. So lambda A means 2A. So it has length 2A. So magnitude is doubled. Direction is not changed. So magnitude of vector A becomes lambda times magnitude of lambda vector A becomes lambda times A, right? So it magnitude of A, it can increase but it is lambda times, like multiply also means times, so lambda times A. So, and direction of lambda A is same as vector A. Okay, So multiplying with, now suppose lambda is equals to minus 1. So this is a, and so opposite to it. So this vector is, so it has the same length, this a, and this is minus a. So multiplying with minus sign changes the direction. So here lambda was your, if lambda is positive, so if lambda is negative, so if lambda is equals to minus a, then the direction is opposite to the direction of, so direction of, so if it is suppose minus 2, so then this was your a, and it is minus 2a, this is minus 2a. So if it is 2a, then first of all as the negative sign is there, so this negative sign means the direction of minus lambda a is opposite. Students, keep on making your notes along with me, okay? Note it down along with me. Direction of minus lambda is opposite to the direction of a or lambda. So its direction is opposite because we have negative sign over here, okay? So students, this is very, very important point, that whenever you have two vectors, like vector a is equals to like lambda b, so here we have positive sign, positive here and positive here, so it means a and b are in same direction. And if I have like second thing, so this was the first thing, now the second thing is that a equals to minus lambda c. So what does this mean? It means that a and c are in opposite direction. They are in opposite directions. Okay. So these are very, very important points. So the direction of minus lambda a is opposed to the direction of a or lambda. And if I have 2 here, so the magnitude will be increased by lambda times. Okay. So that thing will remain the same. So this was about the multiplication of vectors by real numbers with scalars, or you can say real numbers. Multiplication vector with real numbers, and I am treating real number as lambda. So this was your topic 4.3 in your books, and equality of vectors is 4.2.2. okay, now let us move forward. Students, have a habit of reading NCERT books line by line, and if you have any problems you can ask your doubts. Okay, now next topic 4.4, addition and subtraction of vectors by, so addition and subtraction of vectors by graphical method. So yes, so addition and subtraction of vectors, and how we will add them graphically. Okay, so this is one of the method. So you have two vectors. You can see you have figure 4.4 in your books. So you have two vectors, like this is vector A and this vector B. So this is figure A. Now these are free vectors. So free means they are free to move. Look, free vectors, unit vectors, zero vector. So they are all vectors. So here these are the adjectives. What is the meaning of free? Free to move. You can take them anywhere. Okay, keep the direction and magnitude same. So like here you can take this here, you can take this here, you can take this here, but the magnitude and the direction should remain the same. So they are all vector A. So they are free to move. Now unit vector. Unit vector means magnitude is equals to 1. Zero vector, magnitude is equals to 0. So suppose you are writing vector A is equals to 0. This is wrong. Why? Because vector can only be equal to vector. Equality means what? They are both equal. So if you are writing vector here, you need to sign a vector. So that is why we need a zero vector. So zero vector, so A is equals to 0 means this point, nothing. This is dimensionless. It has no dimensions. Magnitude is 0. Okay. So now how we are going to add these vectors A and B. So as they are free vectors, what you can do? Place vector B such that its tail is at the head of vector A. Okay, so this is what you are doing, vector A plus vector B. So place the vector B such that its tail, so this is the head of vector B and this is the tail of vector B. This is the tail of vector A and this is the head of vector A. Okay, so at the head, so this vector A will remain at its place, this vector A. So I'm drawing it again, but you need to move B and you need to place vector B such that its tail, so this is the tail, so bring this tail at the head of A. Okay, so just bring it over like this over here, as it is free vector. So you have brought the B over here. This is your vector B. Okay, so move it from here to here. Okay, so here to here. So this vector B, here also this is vector B. Now simply join. So this is the first step. And what is the step number 2? Join tail of A, vector A, to head of vector B. Okay, so this is the tail of A. This was also a starting point, you can say. So you started from here and you are moving in this direction, and then you are moving in this direction. So here you are, this is your starting point, this is your end point, finish here, end. Okay, so simply join from start to end. And you can also say join the tail of A to the head of B. So that is your resultant vector. So I call this vector A plus B. I also call it resultant also. So R is equals to this. So this is this very simple way of adding, and we call this method as graphical method. Now this was figure B, and in figure C you can see that vector A and B can also be added. So instead of moving B, you can move A also, you will get the same result. So this was your B, and so this is your starting point now, okay? And now move A. So where you will move now bring A here. So this was your A, so bring the A over here, means bring A over here, okay? So bring A over here. So that's your A. Now what is the resultant? So this is your resultant, and you will be writing here B plus A. So students, this was your starting point, and this is here your means final position. So initial position, you can also start it like, say it like initial position, more mathematical way of writing, and this is your final position. You can also give name to these points like your starting point. This is A, this is P, this is Q. So O is your starting initial position, and you move towards so OP plus OP plus PQ, and the resultant is OQ vector. So you can write it also like this, or you can write vector B plus vector A is equals to vector B plus A. Some of the time we also name it like vector R or vector C as resultant, so that's also fine. So you can see that this vector, this is your A plus B and this is your A plus B. So A plus B and B plus A means this vector and this vector. So they both are equal, and we have just studied what is the equality means. They have same direction and same magnitude. So it doesn't matter how you are adding these vectors. So, and we know that this vector addition is, it means vector addition is commutative. So it doesn't matter. So these are the properties, and we call this method, as you are joining the head to tail method, we call it. So we are joining the head with the tail, okay? So head of B with the tail of A. So head to tail method. And now if you have one more vector, which is vector C, and you want to add vector C to it, so suppose we have this vector C over here, this vector C, and you want to add vector C to it, so you can add only two vectors at a time, and now you want to add one more vector, so you will be adding this with the resultant, right? So A plus B plus C. So what is the resultant? This has become now A plus B, right? So we are adding C to it. So adding C to it, suppose. So this vector C. Now same method, joining the head of A plus B with the tail of C. So now again this is your starting point, and now this is your final position. So simply joining these two vectors. So that's equals to A plus B plus C, okay? So this is, you can write this one as, so this was your A plus B, right? And this will be your A plus B plus C. and you can put the brackets over here because you have added a and b first, and then c was added to it. Now you can add c over here also. This was your a plus b, and this was your a plus b, and now I am adding vector c to it. So this is the direction of actually vector c, right? So this is vector c, and forget a and b because you have got the resultant b plus a. So b plus a plus c, so you will get the same this vector a plus b plus c. So it is shown in your book also, that is the figure D. So a plus b plus c is equals to b plus, so you can write it as b plus a plus c. So it doesn't matter in which vectors you are adding initially, but you will get the same resultant. So this was a plus b, and this was b plus a plus c, or you can even add them as a plus b plus c. So you can even add b plus c first, and then you can add a to it. Still you will get the same result. That is shown in your book, figure D. Okay. So that's we call associative law. So vector follows both these laws, and I have discussed this zero vector. You can also call it null vector. So obviously, like you are how do you get this null vector? Vector a minus vector a is zero vector. So like you are applying equal forces, so in this direction and in this direction, so the resultant will be, net force will be zero. Now if you add this zero vector with any vector, result is not going to impact. And if you are multiplying this vector with this zero vector, suppose, as we are studying the properties, so zero vector with any magnitude, so definitely the resultant will be zero. And if you are adding this vector with scalar number, means any real number, so these are real numbers, so multiplying a with 0, so it will become zero vector. So that's how the zero vectors, they have their own importance.
Excuse me, sir.
Yes.
So I just want to ask that, like we have done that a vector plus b vector is equals to b vector plus a vector. We can show this by using arrows.
Yes.
So, sir, how can we show that zero vector?
How can we show?
By using
See,
arrows?
zero vector, I have told you, it's just a point. Okay, the point is dimensionless. It has no direction also. Okay, so that is vector A. You can write this as vector A. This simply this dot. So dot is dimensionless. Magnitude is 0. Okay.
Yes, sir.
And direction is, you cannot specify. So zero vectors, they have the magnitude equals to 0.
Okay,
So these
sir.
zero vectors, they have the magnitude 0, and they have no direction. Means you cannot specify the direction. So no direction. Obviously, if you are not see, if the magnitude is 0, how can you specify the direction? Okay, so you cannot specify the direction of null vector. Okay, good question. Anything else you would like to ask? Okay,
No,
thank
sir,
you.
it's clear.
Now, what about subtraction? So subtraction of vectors. So like that is figure 4.5. So if we are adding two vectors, so that's vector A and this vector B. Okay, so and this was your resultant, so vector A plus vector B, and the resultant is, this was your, so you started from here and this direction and this direction, so that's your resultant, initial to final position. So always join these vectors, students, this is very important. Their heads must join, here also tail and head must join. Okay, means you have to make it a complete triangle, we call it triangular law also. Okay, so this is triangle method of, we can also say it like triangle, so head to tail method you can say, or you can say triangle method of vector addition. Okay, now this is vector A plus B. Okay, we can call it resultant 1, like that is equals to A plus B. Now I want to write A minus B, so I need some space over here. So this is so minus B means same magnitude but opposite direction. Okay, and now this is your initial point, you can call it O, and this is your final point. So simply adding A minus B, so you get here A plus, you have added A plus minus B. Okay, so you have here you have added A plus B, and here you have added A minus B. Okay, and you can write it as A minus B. So these are the, this is how we subtract the vectors. And we have one more way to add the vectors. So addition of vectors, we call it parallelogram method. Like these two vectors you want to add, so this is your vector A. Okay, now instead of joining from head to tail, let us join their tails. So this B, instead of joining the B at the head, joining the B at the tail. So joining their tails now. Okay, so now where will be the resultant? So you need to make a parallelogram first, so equal and opposite, so that's magnitude A, and equal and opposite, so that is the magnitude B. So you have framed a parallelogram. Okay, and this will be your resultant, the diagonal of the parallelogram. Okay, so this diagonal of the parallelogram is your resultant, so that is A plus B. Okay, so that's another method of adding the vectors. And we can also, like this is vector, we have the formula also for the resultant, like that is example 4.2 in our book, and these are the two resultant vectors. Suppose the vector A is over here, so that's this A and this A is different. So this is another question. Okay, so this was, so that is why, and this is vector B. Okay, now you will be making a parallelogram, so that's length A and parallel to A, and that's length parallel to B, and you get here the resultant. So that's my resultant, that is a plus b. So as I told you from the beginning that you need to tell the direction and magnitude of this resultant. So suppose the angle between a and b was theta. So theta was the angle between a and b, and the angle between r and a is alpha. Okay. So what will so here r is equals to vector a plus b. Fine. But what is the magnitude and the resultant? So let us write it with the formula. So r is equals to under the root. So that is your example 4.2 in your books on page 72. So r is equals to a square, magnitude of a plus magnitude of b. So obviously if I writing here only the magnitude, so this side also I will there will magnitudes only, plus 2ab cos of the angle, cosine of the angle between them. And now what will direction of this resultant? So direction of this resultant will be given as tan alpha is equals to. So how shall we write this formula? So first of all you need to see the alpha can be with b also, alpha can be with a also. So whosoever is making the angle alpha with resultant, you have to write that magnitude first. Okay, so here also its magnitude a number, so here also it will be a number only. Okay, so tan alpha is equals to, so alpha is an angle with a, so first of all write a. Okay, and then you have to write b. Okay, so as you have b here, so that, and now you have angle theta, of course you need to involve, and theta is tan means sine upon cos, so simple sine theta upon cos theta. So tan alpha is equals to b sine theta upon a plus b cos theta. So this is the how you find the resultant. Okay, now so these were the graphical methods, and what is the analytical method now? So we have studied two graphical method of addition, parallelogram and triangular. Now what is analytical method? So vector addition, analytical method. So that's same page 71 of your NCERT. So like we have so first of all we need to understand how how we can write, how we can resolve a vector. Okay, so how we can resolve a vector? So like this was vector a, and I need to resolve it along x-axis and y-axis. So resolving of vectors, the previous topic means 4.5, topic 4.5, page 69. So I want to resolve this vector a. So how am I going to resolve it? So simply you can see figure 4.9. So that's figure 4.9b. So this vector a lies in xy plane. So this is your xy plane, this x-axis and this y-axis, and we draw the lines from the head of a. So from the head of a, draw the perpendiculars, okay, on x-axis and y-axis. So very simple. So from the head of a, this is your vector, this was your vector. So from the head of a, join the perpendiculars, draw the perpendiculars, draw the perpendicular on y-axis and draw the perpendicular on x-axis. So you will get this vector as so it's vector ax and this vector as ay. So these are the two components. So vector A is resolved in the components ax and ay. So you can write it as vector A is equals to ax plus ay. Isn't it? Look at this by parallelogram addition. If this is ax plus ay, what you will get? So draw the parallelogram, and this is the diagonal of the parallelogram, isn't it? So this resolving is just opposite to like you do. First of all, I ask you to multiply 3 into 2 and you get the 6. So, and then I am asking you to do the factorization. So this is I was asking you to simplify. Now I am asking you to do the reverse. So the factorization. So here you are making the factors of 6. So that's the same thing. So like I was asking you to do the addition of vector. So you will be writing like ax plus ay is equals to vector A. And now I am asking you to resolve vector A. Resolve. So here you are adding ax and ay. And now I am asking you to resolve vector A along x-axis and y-axis. So we'll be writing it as vector A is equals to ax plus ay. So it's just the reverse. So I hope you have understood it. Now how shall I write vector ax vector? So I told you that this is I cap, and this magnitude is equals to ax, and this magnitude is equals to ay, and this vector, unit vector in this direction, this is j cap. So you can write this vector A is equals to the, how will you write ax? If any vector, so its magnitude and its direction by the unit vector multiplied with the direction. So its direction is I cap plus the magnitude of ay vector, that is this. So just remove this vector sign, so this magnitude, and multiply it with the unit vector direction. So that's how we write ax plus ay. Now we have how do we write similar way vector B? Vector B as, so change A with B. That's the only thing you need to do. So bx I cap plus by j cap. Now add A plus B. So A plus B. So now the components of you can simply see this is ax I cap, and where will be bx I cap? Of course bx I cap will be in this direction only. Okay, so if they are in same direction, like you are applying the force 2 Newton and one more boy is applying the force, you have a rope, so he is applying the force of 3 Newton suppose. So what will the resultant? So the resultant will of course be 2 Newton plus 3 Newton, that is equals to 5 Newton in the same direction. So if it was, so direction will remain the same. So if this x-axis along x-axis, so your answer will also be along x-axis, right? So it's so simple if both are in same direction. So it's so simple to add, and that is what we are doing. So we have resolved them along x-axis. And now simply we simply need to add there. So the direction will remain the same, and their magnitudes will be added. So ax plus bx, but the direction will remain the same, and that is I cap, isn't it? So it's so simple to add this analytical method of adding. And now add their y components because they are in same direction, so they will be simply adding. So ay plus by j cap. So this is the analytical method of adding. Now another important thing is, how do you write the magnitude of this? This A is suppose making an angle theta. So this was your ax, and this was your, this magnitude is ay. So let us draw it again. So this was your vector A, So its magnitude was A, and its magnitude is AX, and its magnitude is AY. So simply if we write it in terms of geometry, so what is the magnitude of vector A? So magnitude of vector A is equals to, by Pythagoras theorem, so A will be equals to AX square plus AY square. So that's the magnitude of vector A. So these are the three vectors, but AX, AY and resultant A. So that's your hypotenuse, right? So resultant vector is your hypotenuse, and tan theta is equals to so in this formula, so base upon perpendicular upon base, so perpendicular is your AY and this is your AX, and you can write it as theta is equals to tan inverse AY upon AX. So that's how we find the magnitude. Okay, so magnitude of vector A is actually a hypotenuse, and that is equals to the under the root perpendicular square plus base square. So this we already know. Okay, so not a issue. And now we have we have understood how to add the vectors. Now how to multiply the vectors. So now multiply, or you can say product, that's the same thing. So multiplication of vectors, or you can say more commonly we use, instead of multiplication, we use the word product of vectors. So now we have two kind of products. Some of the time what happens is that we get as a product we get a scalar quantity. So as after the product, if the product of vectors is scalar quantity, like we have studied that f dot s, so if you are multiplying f and s and you get a scalar quantity, that is your work. The work is a scalar quantity, no vector sign over there. But some of the time you get product as vector quantity also. So scalar quantity and product as vector quantity. So these are your products. So if the product is a scalar quantity, then it's a, we call it dot product. Okay. And if the resultant is a vector quantity, like that's what we are going to do in this chapter. So look at some formulas which are involving the product, vector product, and the first formula that we will be dealing with is which involves the vector product is, so torque, the force which is responsible for the rotational motion. So what is the force that we have written the in the rotational motion centripetal acceleration we have written, and even the linear velocity we have written, but we have not written the force. So force, so rotational force, the force which is responsible for the force responsible for rotational motion. So that force is torque. We call it torque. Okay. So this is the symbol tau of the torque, and that is equals to R cross F. So we'll be doing this. So very prominent formula. So R cross F, and the resultant also is a vector quantity. And after this we will study another important formula. So that's your equation 7.23. Now L is equals to R cross P. So tau is equals to R cross F, L is equals to R cross P. So this was your linear momentum, and that's the L is your angular momentum. Okay, so this is another vector formula. What about this formula? You know, there is one more formula, that is v dot v, that also we use prominently, that is v square if they are same. Now another formula, one more formula, the related with the cross product that we are going to use in this chapter, and so that one is okay. Let us write these two formulas for the time being, very important formulas. So the cross product, so this is dot product, these formulas are of dot product. So if the resultant is a scalar quantity, it's dot product, and if the resultant is a vector quantity, I call it cross product. So you can see this multiplication sign of cross, we call it cross product. Okay, so and now what are the so dot product was introduced in chapter number 6 and cross product is introduced in chapter number 7. So if you want to know more about the dot product, that's chapter 6, beginning of chapter 6, dot product. So if you have two vectors a dot b, and the resultant will be written as a magnitude of a into magnitude of b into cos of theta. Okay, so and we know that here the commutative law is applicable for the dot product. A dot b is equals to b dot a, so that's commutative. And the third thing is distributive law. So a dot b plus c is equals to a dot b plus a dot c. So simply distributive law. And if we write like here, we did the addition of vectors, simply adding their x components. So here a dot b means simply multiplying their x components. Okay, and you can derive it also if you want to derive it. So simple. A dot b means what? It means what is vector a? So vector a, so you have to write vector here also, ax vector I cap plus ay vector j cap dot bx I cap plus vector by j cap, and simply if you are means multiplying them, so ax dot bx, so what will be ax I cap dot bx j cap. So if you are you will be writing here the magnitude of ax and the magnitude of bx, and what is the angle between both of them. So angle between I and j, so okay, so students, as you are writing here x and I cap, so here there will be no, because you are writing the magnitude of ax, so no vector sign. You are writing the magnitude of bx, so no vector sign. Okay, so you have written here ax I cap and you have written here x. So how will you write a vector? So here also there will be no Of course there will be no, we are writing this simply the magnitude. So this was your vector A, and this was your vector B. So it's magnitude in A direction, and it's magnitude. So isn't it, this is AX plus AY. So if you're writing it in vector form, then you have to write it this way, and BX plus BY. Okay, don't get confused. So now if you are multiplying this, so what about this dot product means magnitude of this vector and magnitude of this vector, and then the cosine of angle between this. So you know that this is j cap in y direction, this is I cap in this is, so the angle between them is 90 degrees. So what is cos 90? So cos 90 is 1. That is why you get AX BX. Okay, so it means I dot j is equals to 1, isn't it? So dot product, your answer will be a scalar quantity, a number, and so as their magnitude is 1 1, so that's this. And if this is I dot I, cos 90 is 0 actually, sorry, cos 90 is 0. So if you are multiplying this, but I was multiplying here AXI and BXI cap, so this is I cap, students, sorry, and this is I cap. So I cap dot I cap, so the angle between them is 0, not 90, and cos 0 is 1. Okay, so cos 0 is 1, and I dot I, so this is I dot I. We have done it earlier also, so it's so simple. So I dot I is equals to 1 because the angle between them is 0 and cos 0 is 1. So I dot j is equals to 0, and even j dot k because the angle between them is 90 degree. Okay, so that's how we get this. So these are the two prominent formulas. So same students, in the same manner we will have the formulas for the cross product also in a similar way. So A cross B is equals to A, magnitude of A into magnitude of B into the, now this time sine of angle between them. Okay, now there is one more thing, that as this is a cross product, so here the resultant is vector, so I need to tell this direction, tell the direction of this. So this magnitude multiply with direction, so that's n cap. So that's very important to understand that what's the direction. So this is your so you can look at figure 7.15. so that's the figure you need to see. So A cross B, so this is your vector, suppose A, and this is your vector B. So you can also write these vectors with the small letters, this vector A and this vector B. So, and this is the angle between them, that is theta. So the important thing is that you need to start the angle from A to B. Okay, A cross B means A to B. So you need to take your right hand and put your right hand fingers on A. Put your right hand fingers on A and you know, curl them towards B, or you can say put your right hand means on A and move your right hand keeping the thumb in the same direction. Okay, thumb is of course make an angle of 90 degree between your fingers and thumb. Okay, make an angle, put it on your table, your right hand, and thumb must be 90 degree with the fingers. Okay, or the fingers are straight horizontal and the thumb is vertical. Okay, and now simply keeping your thumb fixed in vertical direction and move your all the fingers move from A to B. Okay, so A to B. So what is the direction of the resultant? So the direction of resultant is vertical to the table, isn't it? So if your table is x-axis is in the xy plane, your table, so the resultant will be in the z plane. Okay, so this is your z-axis. So this will be your n. So this is the most important thing, how to find the direction. So, or you can simply curl your fingers from A to B, your thumb will. So this is the direction of your thumb. Okay, so that's z-axis. So this was your, suppose, xy plane. So A and B in xy plane, they are in xy plane. So this resultant will always be perpendicular to the direction of the plane containing A and B. So this resultant, this resultant vector, that is A cross B, this resultant vector will always be perpendicular. So perpendicular to plane containing A and B. Okay, so cross product is always perpendicular. So where will be this cross product? What is the direction of this n cap? That's the same thing. So direction of A cross B or A cross B will be in the direction perpendicular to plane containing vector A and vector B. I hope this is clear to you, and you can just use your right hand thumb. So curl the fingers of your right hand or simply move the fingers of your right hand. So by right hand curling the fingers from A to B, right hand. So fingers of right hand move, you can say move or from A to B. So thumb will give you the direction of resultant, that is A cross B. Okay students, so this is the important point here, because here the direction was not involved, here we have the direction is involved. I hope this is clear to you. Very simple. So what will be the direction of the resultant, isn't it? So magnitude is simply this thing. Okay, what is the direction? Direction is perpendicular to the plane containing A and B vectors. Okay, now the second thing is, so this was the first thing. What about the second thing? Second thing here is A dot B is equals to B dot A. What is B dot here? So now see, you have to move your fingers from B to A. So where will be the thumb? Now the thumb will be vertically downwards. So how can you move your fingers? So now your thumb was vertically upwards. Now change the position of your hand and right hand with the thumb vertically downwards. And of course the fingers are, the angle between the fingers and the thumb is 90 degree. Okay, so now put your this right hand, fingers of the right hand on B and move them towards A. So you can do it in the, like in the air you are doing it. Okay, so B to A. So the thumb will be in a downward direction. So here the direction is changed. Okay, so how will you make this figure if you want to make? So this is like your vector B, and this is a vector A. So this was a vector B and vector A. So what is the direction? If this is this was your direction n cap, so this is your direction minus n cap. Okay, so that's the direction. So this will be equal. So this was and this was your direction n cap, unit vector in this direction, and that is minus. So this will be the direction. So the direction is changed. Magnitude is the same. B A sine theta. So there is no change in magnitude, but the direction is changed. So now the direction is minus n cap. Okay. So put this value A cross B here. Negative will come out, and that is equals to minus A cross B. Okay. So B cross A is equals to minus A cross B. Okay. So here it was following the commutative law, the dot product, but the cross product does not follow the commutative law. Does it follow the distributive law? Yes. Distributive law it is following, like A cross B plus C is equals to A cross B plus A cross C. So distributive law it is following. There's no problem with the distributive law. Okay. Now what about the fourth thing? So this is sort of fourth thing. So what will be I dot I here? So I dot I will be magnitude of I is 1. Magnitude of I is 1, and then sine theta. So what is sine of so I and I both are in same direction, so sine 0. So here I am finding the cross product, right? So A, B and sine theta, and direction is also there, of course. Okay. So what will be the direction? If I ask you to write the direction here, so what will be the direction? What will be the direction here? Yes, who will tell me what will be the direction? I cross I. Yes. What will the resultant of this?
No direction.
Yes, no direction, because this is the magnitude is 0, so it's a 0 vector. Okay, so it's a 0 vector, and because this is sine 0 is 0, so 0 multiplied with any vector we have done earlier, and that's 0 vector. So it has no direction. Direction is not specified. We cannot tell the direction. Okay, and what about I cross J? So I cross J, here the magnitude is 1 and then 1. So move the fingers from x-axis to y-axis. So where will be your thumb pointing? Thumb will point it in z direction, isn't it? So this is sine 90 degree, and where will be the direction? It's in z direction. So that's k cap. So that's equals to. So it means that I cross J is equals to k cap. So here so here I dot y I was equals to 1, but here I cross I, because here we are considering sine angle and here we are considering cosine. And students, what about J cross I? So see here, B cross A is equals to minus A cross B. So of course here it will be minus zx, because now you are moving your fingers from y to x plane. So now your thumb will be pointing downwards. So of course this will be equals to minus negative k, and negative will come outside. That will be equals to I. So that's equals to minus k cap. Okay, and k cap is equals to I dot j. So we can simply write it as that j cross I is negative of I cross j. Okay, so that's the difference, students. So if you are, so you need to very particular. So how you can remember this? What's the way of? You can simply make a circle. Okay, and this is I cap, this is j cap, and this is k cap here. Okay, so I cross j is I cap cross j cap is k cap, and then j cross k is I, and then k cross I is j. So move it in this direction. Okay, so j cross k is I cap, k cross I is j cap. But if we are moving in opposite direction, like j cross I, that is minus k cap, I cross k minus j cap. Okay, so this way we write the cross product for the unit vectors. And what about this thing? This is another important formula. So how you will be writing this? So fifth thing, so like here you have written this formula, so how you will be writing it here? A cross B. So A cross B is written as IJK. This is determinant form. This is the first time that you are learning it, but it's so simple to write. So we have like A cross B. So vector A, you know that it is written as AXI cap plus AYJ cap plus, so now we are resolving it in, so now this vector is in plane, so it is resolved in all the three on all the three axes, and vector B can be written as BXI cap plus BYJ cap plus BZ K cap. Okay, and here it will be written as A cross B is equals to IJK caps, and then they can be written as small also, in small letters also, the magnitude. Okay, so if it is in small letters, then AX, AY, AZ, it's so simple to write, and then BX, BY and BZ. Now how do we solve this determinant? This is the first time. Okay, now how do we solve this determinant? How do we write it? So it's it is written as like for I cap you will be writing, so when you will be writing it for I cap, what you will be doing? So hide this, put your hand on this I cap. Okay, put your hand over here. Okay, hide this. So when you will hide this, like you have hidden this, what you are left with? So you are left with AY BZ, so this crossing AY BZ, okay, minus this crossing, okay, AZ BY. I hope you have understood this, students. Now okay, so hide this and you will write it as AX BZ minus AZ BY. Okay, this is now plus, so this is a cross product, so I'm writing it in similar way, means along the component. So this is the component along x-axis of A cross B. Now what about component along y-axis? So hide this y-axis, and this will be now in the middle. You have to change you have to start with AZ first. Okay, so instead of here we started with like this is not AX, students, this is AY. Okay, so here it is X, so of course B and Z, and now this is along the J cap, so hide it, and what you are left with? So if you hide it, so what you are left with? So from the middle you need to earlier we started from this side, so now you will be starting from this side. So this is the thing you need to remember. So you will be starting from Z. Okay, so the sequence, as I told you, will remain the same. So if x to y and then y to z. So here and then z to x. So if you are multiplying z and x means component, so start from the z. Okay, if you had y and z, from where you will be starting? You will be starting from y to z. Okay, now here I have j cap. So what you are left with? I cap and j cap means x components, x and y and z components. So z to x. So this is another way of remembering it. Okay, we can derive this formula also, but I have told you simpler way to directly write it. Okay, so derivation is there in your book also on page 152. So az and then bx. Okay, minus then ax bz. Okay, and then plus so you have it in j cap. So obviously we will be starting with from z az to bx, az into bx minus ax bz. Okay, so page 152, these formulas are there. Students, just revise it properly. Now what about the component of a cross b along z axis? So now hide this and you are left with x and y. So what you will be x and y? So x to y. Okay, so ax by minus ay bx. So minus ay bx. Okay, so students, this formula a dot b was this, and here a cross b is this. So these are the signs of determinant. You will be studying a chapter, determinant. A full chapter is there in your book, matrices and determinant, 12th class mathematics. So but now we just so you have, so these are also the basics for you. So you have one chapter dedicated to vectors, okay, in class 12th. So one full chapter of vectors. So these are the basics, but here we are doing, so quite important for 11th and 12th class and for to understand this chapter. So students, that's all for today. Now if you have any doubts, you can ask your doubts.